So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, we have started our new series regarding the selection criteria of solenoid valves. We have seen many parameters in detail in previous sessions. You can check out those things also, and today we will see an important parameter which is called as response time of the solenoid valve. It is nothing but the on and off time of the solenoid valve. The values are in milliseconds but can cause a lot of difference according to your application. So do watch the video until end and don't forget to subscribe the channel and hit the bell icon for getting updates of the upcoming sessions. So without wasting time, let's get started. So what is the response time of the valve? Let's check out. So the response time of a solenoid valve can be defined as the interval between the moment of the actuation of the solenoid valve until the pressure has fallen to 10% or raised to 90% of the maximum test pressure. So this is the off time and on time of a solenoid valve. So those values are dependent on many factors. What is the type of the valve, what is the voltage, AC or DC, and many things. If we see the type, the response time is depending on the construction of the valve, the coil properties, atmospheric pressure, viscosity of the medium. So there are a lot of parameters which affect your response time, so you should know all these parameters of the medium and all those things. The response time of the DC valve is bit slower than AC valve. Yeah, the DC valves are a little bit slower than the AC valves. Then again we have direct operating valves which are generally faster than the indirect valves, right? So because in the indirect valves we have diaphragm and the pilot pressure and all those things, so it takes more time for the actuation, right? The common valve values for the direct operator valves are between 5 to 50 milliseconds, right? And for indirect valves the same time will vary in a range of say 50 milliseconds to 1500 milliseconds, also for the large versions having large flow rates, right? So this is about the response time. It is dependent on many factors. So let's check out the solenoid valve response time article, and it will throw some light and will have some in-depth knowledge about the response time, how it affects. So let's check it out. And also for application, the short response time is not considered. For example, the water hammer. So in case of water hammer, if the response time is shorter, it can cause the damage to the system. So it is not that in all the cases you require the shorter response time. You should know the application, and that's how the valve timing matters. Not all solenoid valves have the same response time. Definitely the different valves have different response time, right? As we have seen, the direct solenoid valves have shorter response time while the indirect valves have longer response times. Then based on their sizes the response times vary, and also you can see the on time and the off time is also different. You can see the response time for closing the valve is defined as the duration from de-energizing the solenoid until the pressure drops to 10% of the test pressure. The test is executed with air at 6 bar and 20 degrees Celsius. So there are some standards at which these values have been calculated. So if your environment is at different temperature, the values will definitely change, right? So we should know at least what are the standard times of the valve, because these things matters a lot if the cycle time is crucial, because these values gets add up into your cycle time. So if you are dealing with the cycle time and you want to reduce the cycle time, let's say 0.25 seconds, so these things also matters a lot. So that's why you should know these things. So from mechanical point of view, it takes amount of time for the armature to move the required distance after the magnetic force is acted upon it to overcome the spring force. So if you see, the response time is made up of both the electrical and the mechanical things. So both electrical and mechanical constraints dictate the response time for a solenoid valve, right? So whether it is your construction, mechanical construction of the valve, and whether it is a DC valve or AC valve, that is the electrical parameter and the mechanical parameter combinedly determine the valve timing. So here is just a comparison of the wall. You can see the wall pipe type, and then the open and closing times. You can see the 1/8 inch pipe size and the timing. So as the wall size increases, you can see that the timings are also increasing, and also you can check that the open and close times are not same in all the cases. So yes, definitely the opening on and off timings might not be same. In some cases those can be same, and but there is no rule that both the times will be same, right? So you also have to consider these things. You cannot assume blindly that the open and close times are same, right? So these are in milliseconds, but when cycle time is crucial, these things also matter a lot. So you can see, and then some water hammer effect. They have mentioned if the wall timing is very less, it can cause a huge problem in case of water hammer effect, right? So this is all about the response time of the walls and how it is defined and how it affect your application and all those things. So while selecting the wall, you must check what is the response time of the wall. It is mentioned in the catalogs, so you should check out these things before selecting the wall. So this is it guys for the today's session, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making, and thank you for the patient listening. Thank you.